Now, I want us to look at a different topic today, that is chemical structure and bonding. Now, we know that atoms, we have already looked at atoms, and we have said that our elements are made up of atoms. Now, atoms have three main particles. Atoms have protons. Protons are positively charged. They also have electrons, which are negatively charged, and then the neutrons, which are chargeless or have no charge. Okay. Now, bonding is normally achieved when there is attraction between the like and unlike charges, that is the positive and the negative charges. Now, we have the following types of bonding that can occur between atoms of elements or different elements. We have ionic bonding, which is the total transfer of electrons from one species of an atom to another. And then there is covalent bonding, in which there is a pair sharing of electrons. And then we also have metallic bonding, formed when metals normally lose the localized electrons. And then we have coordinate-rotative bonding. Now, in coordinate-rotative bonding, the electrons shared come from one species of one atom. Then also we have hydrogen bonding. Okay. Now, hydrogen bonding, coordinate bonding, rotative bonding are all types of covalent bonding. Now, let's look at the formation of ionic bond. How does ionic bond form? We have said that in ionic bonding, the electrons are transferred from one atom to another. And a good example I want us to look at is the formation of sodium chloride, table salt. We know that sodium has 11 electrons. And sodium has 11 electrons. Whereas chlorine has 17 electrons. And we know that normally atoms achieve stability by expressing the stability of the noble gases, that is either through the octet, that is if there are 8 electrons, or what we call the duet, 2 electrons. Like you have seen in the electron configuration of various atoms that we have done sometimes back. Now, I want us to look at the formation of the ionic bond, that is the bond between sodium and chlorine. We have said sodium has 11 electrons, chlorine has 17. Now, we can do this way. The first 2 electrons in the sodium are there, remaining 9. Then we have this other one, the next 8. This the first orbital or energy level in the sodium has a maximum, can only have a maximum of 2, what we are calling the 1s2. Okay. Second orbital has a maximum of 3. A maximum of 8, sorry. 1, 2, 3, 4, 5, 6, 7, 8. This normally, second orbital normally is made up of the 2s and the 2p. So the 2s has a maximum of 2 and a maximum of 6. Now, only one electron is remaining hanging, will occupy the 3s, making them a total of 11. 2, 2, 6 plus 1 is 11. So we are joining this sodium, this is sodium, we are joining it with chlorine. Okay, chlorine. Chlorine has 17 electrons and its atom is a bit larger than the sodium. So the first 2 electrons of the chlorine are that one. The next 2, the next 8, which are the octet, they're forming the octet, the 2s and the 2p. Again, there are 8. 1, 2, 3, 4, 5, 6, 7, 8. Plus that 2, 10, remaining 7. So you can remove this other one, this extra orbital. So these ones are 7, and then the remaining 7. 1, 2, 3, 4, 5, 6, 7. We want to form a compound called sodium chloride, which we have said is formed by linkage or an attraction between the positive ions, what we call the electrons of the sodium, with the negative ions of the chlorine. Now, for the sodium to become stable, it has to lose the outermost electron. Okay? It has to lose the outermost electron. If we were to do this chlorine, if we were to do the configuration for the chlorine, we will have said 1s2, 2s2, 2p6, the total of 10, 3s2, that is we have 2 plus 2 plus 6, 10, plus 2, that is 12, and then 3p. So we have 2, 2, 10, 12. So p can hold a maximum of 6. When we add the two, when we add this together, 1, that is 2 plus 2 plus 6, that is 10, 12, 18. And remember, they're supposed to be 17, so we make it 5. Now, sodium becomes stable when it loses this outermost electron, whereas chlorine becomes stable when it gains an extra ion or electron. So sodium is going to donate the remaining electron in the outermost orbital to the chlorine outermost orbital to make it complete or to make it stable. That way we are going to form a sodium chloride, which is a type of ionic bonding. So we come here, we draw our orbital for the sodium. Because we are going to lose the outermost electron in this particular orbital, we are going to do away with this orbital. So we are only going to have 2 orbitals or energy levels. That, and then these are the 8. Because now it is stable, it is charged now. Okay? Remember, positive. Now we know the formula for formation of sodium chloride. It is sodium chloride, so it is 1, 1. So you can draw the other one. Now our chlorine has gained an extra electron, so it is still going to maintain its outermost orbital or energy level. So we draw it. So the first orbital, the second, 1, 2, 3, and then the last one. So all of them are completely filled up based on the octet duet rule, duet octet rule. So we have that. So you say that chlorine is normally negatively charged, it is an ionic, whereas sodium is a cationic. So the compound we form is called sodium chloride. Now this is the bond formed between sodium and chlorine is ionic bond. That is how we form the ionic bonds. Thank you.